Well, here is the semester 2 final review that we're going to go over. So, number 1, the coordinates of a parallelogram. I'm going to go ahead and plot that so we can see what it looks like. So P is at -3, 0, which is here. Q is at 0, 4. R is at 4, 1. S is at 1, -3. And you can see that this is actually going to be a square on its side. So all these are the same length. You can even count the slope or the distance formula, and you can compare it. But the answer is then B, a square. So number 2. Then it says, which statement is true? All quadrilaterals are parallelograms. That's not true. Parallelograms are a type of quadrilateral. B, rectangles are, all rectangles are squares? No. Only if the rectangles, all the sides are the same, then it'd be a square. C, all quadrilaterals are squares? No. Squares are a type of quadrilateral. D, all parallelograms are quadrilaterals? Yes, it is D. Quadrilaterals are 4-sided shapes. 3, consecutive angles in a parallelogram are always, it's not vertical, they are always supplementary. The same side interior, if you think. So like, if I call this angle 1 and this angle 2, those have to add up to 180. Otherwise, these two lines would not be parallel because they're same side interior. So number 3, the answer is B. 4, choose a statement that is not always true. For any parallelogram, opposite angles are congruent. That is always true. B, the diagonals are perpendicular. It's right there actually. Only in a rhombus are the diagonals actually perpendicular. So that's only sometimes. C, the diagonals bisect each other. That's always true. Opposite sides are congruent. That's always true. Number 5, you gotta draw a Venn diagram, relationships between squares, rectangles, rhombus, parallelograms, and quadrilaterals. Well, these are all types of quadrilaterals. All the 4-sided shapes are. And then squares, rectangles, rhombuses, those are all a type of parallelogram. Let me do it this way. So parallelogram here, and then within that is all the other shapes, because the square is a type of parallelogram, and it's also a quadrilateral, rectangle, rhombus. Those fall inside. Number 6. It says 2, 3, and 3, 1 are opposite vertices in a parallelogram. Well, let's plot this out so we know what we're looking at. If 0, 0 is the third vertex, okay, so we have it looking like this, all right, then the 4th vertex is, and so what you can do is see how this goes down 2 over 1. In the same way, this is going to go back 1 up 2 to make my other point. It's the same slope. Just make sure that these lines are parallel and you know you did it right because it's a parallelogram. So those slopes, the opposite side, should have the same slope, which is down 2 over 1. Number 7. Then the 4th vertex is, and this is at the point -1, 2. So that would be your answer for 6. 7. How long is a string reaching from the top of an 11-foot pole to a point 5 feet from the base of the pole? So here's your 11-foot pole. Here's your 5 feet from the base. You have this string coming down. You want to find out what that is. That's just Pythagorean theorem. So 121 plus 25. So C equals the square root of, and you add those together, 146. So the answer is C. Numero ocho. Triangle ABC, we're looking for the hypotenuse. So this is 6 squared plus 9 squared equals C squared. This is actually, oh no, it's not that great. 36 plus 81 equals C squared. C equals the square root of 117. So the answer, and the square root of 117, let's see, 3 goes into it. So we can rewrite the square root of 117 as 3 times, hang on 1 second, 3 times 39. 39 I know breaks down to 3 times 13. So there's a pair of 3's that I can take out. So it becomes 3 squared of 13 after I simplify. So my answer is actually B for number 8. 9. For each set of numbers, determine whether the numbers represent the length and size of an acute triangle, a right triangle, or an obtuse triangle, or no triangle. So to be a triangle, your small side plus your medium side have to add up to be bigger than your large side to be a triangle. If your a squared plus b squared equals c squared, then it's a right triangle. This Pythagorean theorem would work then. But if you had a squared plus b squared and actually have your c squared be smaller, your hypotenuse shrinks, if you will, then it's going to be an acute triangle. And if you had where your hypotenuse was bigger, it would actually make it into an obtuse triangle. So those are the factors to think about. So for number 9, we would do the square root of 7 squared plus the square root of 66 squared equals square root of 72 squared. And actually we want to figure out, does it equal it? Is this bigger? Well, this becomes 7 plus 66 equals 72. I'm going to put a little question mark here. I'm really asking, is it equal? Or what's the relationship? This becomes 73. So 73 is bigger than 72. So that means we are actually talking about an acute triangle because my hypotenuse is smaller. So this would be an acute triangle for A. Now let's check out B. We have 16, 19, and 34. So we'll do 16 squared plus 19 squared and see how that compares to 34 squared. So we'll put a little question mark in between there. 16 squared is 256. 19 squared is 361. 34 squared is 1156. And you can see that 256 plus 361 is going to be smaller than the 1156. So my c squared is bigger. So that means that my hypotenuse grew, so it's obtuse for answer B. And then for C, those numbers 2.8, 9.6, and 10. When we do 2.8 squared plus 9.6 squared, we're going to see how it compares to 10 squared. .84 plus 9.6 squared, 92.16. See how that compares to 100. And it actually equals it perfectly. So this is a right triangle. Let me see how we're doing here on recording. Looks good, just running out of battery. All right, number 10, it says find x and